Okay, hi everybody. Should I shout really loud for the people that were at Skrillex? Or is this the people that weren't at Skrillex? Right, I'm not quite sure. It was pretty loud last night. Let's see my slides. There it is. Everything's already messed up here. Okay. So I'm Adrian Cockcroft, and I'm going to talk to you about cloud-native cost optimization. And this is a new talk. It's basically something that I've been thinking about for a while, and I'm trying to sort of get my thoughts out. So the first time I've given it, and I'm looking for feedback. Quite a bit of this is based on a talk that I did jointly with Jinesh Varia of AWS at Cloud Connect about a year and a half ago. So there's some slides where I just copied the stuff over, and the rest of it is sort of my new thoughts around that. And this thing has decided it's not going to work. Come on. Give me my new slides. Do something. All right. I shall push buttons manually. This. What is going on here? Ah, that got my slide. I don't know what I just did, but it seems to be working now. All right, so what does everybody want? It's like a universally good thing. So there's two things that everybody wants. They want to take less time, and they want to spend less money, right? I don't find anybody that says, I want my products to cost more and take longer to build, right? Everybody wants the opposite. So I've been spending most of this year doing a talk that's aimed at speeding things up. Speed and scale, fast delivery. There's lots of times I've given that talk, and you can go find copies of it. Pretty easy to Google them up. There's videos and all kinds of things. I've got some links at the end. But this talk's a new one, and I'm trying to talk about how the effect of using cloud-native architecture on costs, how you can optimize it and just how to think about it. It's not a particularly technical talk in terms of specific features to use, but it's talking a lot about the cost modeling and how to think about these things. So start with, how do you measure cost? Where do you start? There's really three different ways that you can measure cost. One is bottom-up. You look at the cost of all different components. The other one is based on what does it cost to get a product out, sort of incremental cost. The other one's top-down. So what do I mean by that? Bottom-up. Here's a machine. What did it cost to buy that machine? How much does the electricity cost? How much does the building you put it in cost? Add all that up. How much time do you spend looking after it? You build everything up from the bottom. So quite a lot of costing's done that way. Product cost is the cost of getting something new into production and the cost of keeping it in production. That makes some kind of sense. That's the way that sort of developers tend to think about cost in terms of product cost. And the other one's top-down. Divide the total budget by the number of components. So let's say you've got your total IT budget is $10 million a year, because that's what the CIO's budget is, and you're running 1,000 machines. That means you have $10,000 per year as the fully burdened cost of your machines. I mean, you can play with the ratios, but you're doing a top-down, and you're having to allocate all of that budget to something, right? And you take it, what is the productive output of that organization? Maybe it's those 1,000 machines. And there's other stuff they do, but it's not really productive output. So that's kind of a fully burdened cost. What happens is when you compare top-down and bottom-up, they never meet in the middle, and it's a very instructive thing to try and do. It's a great exercise if you're doing cost modeling to try and make them meet. They usually, if they're only out by a factor of 2, you're doing really, really well. We did this at eBay back in 2006, and we were consistently off by a factor of about 3 when we were doing it, because the top-down was always way more than what we thought we were spending when we did it bottom-up. So. Very, very useful, and when you finally figure out what the differences are, you discover all of the hidden subsidies that you'd forgotten about, and then there's all the hidden costs that you'd also forgotten about. But typically the hidden subsidies are much bigger than the hidden costs. That's why it all comes out wrong. And your math never adds up because you miss things, and you're counting VMs instead of machines, and there's all these things that never quite match up. But if you look at the product delivery cost, it's all different, because now you can look at it from the point of view of a development team that's trying to build this, like an agile team that owns the DevOps sort of, I'm going to define the product, I'm going to run it, I'm going to build it and run it and do everything. And what they look at is what is the value delivered for this product versus what it costs to put it into production and run it. And this, what matters a lot is time to value. How quickly does this thing that you started building, you started spending money on building it, how quickly did you start getting value out of it? I mean, the value might not be exactly dollar value, but there is a reason that product's being built. It might be just a microservice in the back end. But so time to value matters because then you start getting your return and that starts offsetting your costs. If you take too long to build something, then you have to get more value later. So a lot of this is calculating return on investment, net present value, and its minimum marketable features to get stuff out earlier. Those are kind of the things that are going around. And this is also one way that you switch to thinking about your deployment as profit center rather than a cost center. Right? A lot of IT says, well, we're a cost center. We want to figure out how to be a profit center, right? That for the business. And this is really how you do that. You're looking at, I'm getting a value, I'm spending money to get that value. What's the difference over time? I'm going to talk a bit more about where do cloud costs come from and how do you think about that? And this is just a sort of a summary. First thing is optimize for speed first, because if we get something done quickly, it's going to cost you less. You're getting value more quickly, and you're not spending so much time on the sort of meetings and all of the overhead of getting it done. So once you've got everything done quickly, then you do a sort of a late optimization. Once you've got it in production, you see where the real costs are, and you start optimizing. And most of optimizing in the cloud comes from turning things off, because then you don't have to pay for them. And only buying capacity when you absolutely need it, on demand. And then you do consolidation of workloads and by reservations. And you can also plan in if you're looking at sort of a 3-year costing, you want to plan in price cuts. You want to have some model for how you expect prices to decrease. And then there's a lot of open source tooling you can use around this. So, you might want to look at, some of your data center costs quite often include sort of data center agents for doing things, and there's lots of management tools that are fairly expensive. Or sort of the cloud tooling is either bundled into the product for free, or, like the Docker launching service that Amazon had, it's included. You don't have to go and buy, a license to run Mesos or something, from Mesosphere to support it like you would in your data center. So a lot of these tooling, it's basically bundled, or you can get free versions versus having what you'd be doing in the data center. So one of the things is that you can play around and do things that would normally be impossible and do them immediately. And this is a couple of examples from my days at Netflix. The launch into Europe a few years ago, they launched a bunch of machines in Amazon Ireland, and there was no real planning. There's no people in Ireland. There's no engineering in Ireland. As far as I know, nobody from Netflix has ever visited the machines. Right? We sent some executives over when we did a product launch to talk to the press, right? But nobody went and visited the computers, right? So normally, if you're going to launch in a country, you have to hire people, and you have to find a building, and there's a lot of, you have to set up a legal entity in that country so that you can go and manage all this stuff. It's much more complicated. We also over-provision it on day one. In fact, we told Amazon a few weeks in advance we need about 1,000 machines. Turns out we needed a couple of thousand machines by the time we got there. And then once we got it launched, scaled down all of the different services that we'd overscaled to start with. So once you get the real launch capacity, you can shrink to fit very soon afterwards. But if you think back, there's never been a launch outage at Netflix due to capacity. There's always been enough capacity to do the launch. The other thing we did was we tried proxying sort of setting up some network proxying to get better latency by setting up some machines in Brazil. Setting up stuff in Brazil is really difficult. So import tariffs, it's a long way away. It's a difficult thing to do. It's trivial to do anywhere that there's an Amazon region. And then we decided it wasn't good and shut it all down after 2 weeks. So if you've just spent a lot of time setting up infrastructure in a country and you say, I've changed my mind, how to piss off your IT department. Right. So let's think about capacity planning. How do you know how much capacity you're going to need? So you're going to get this product out, and somebody sits there and works out, we're going to need 100 machines to launch this product, right? And to run it. And it's a guess, right? And that's the way. So you go and allocate some data center capacity, and you buy some hardware and put it in your data center, and you hope that you got it right. So there's 3 possible outcomes here. So the best possible outcome is you get it exactly right. You have a little bit more capacity than you think you're going to need long term. You put the capacity up front, and then you start working on your build out, and the product's a bit late, so the capacity's sitting there idle for a bit extra time than you expected, right? Because nothing ever happens on time. And then eventually you launch, and then you grow up, and then eventually you know, after a few sort of growth phases, you're still at about that 70% level, and you're comfortable headroom on that, right? Because it takes a lot of time to put the capacity in the data center, right, compared to cloud. So you have to have that capacity up front. So the point here is that the cloud, the red curve here, or the red line, is just a little bit more than the demand level, yeah, at every point in time, so that you're never having extra capacity. And that dollar sign shows that there's a large area where you bought stuff months before you needed it, and you bought more than you needed, and you had to sort of lay it in up front. Now, obviously, you could optimize this. You could maybe buy your data center capacity in a more agile way, buy it piece by piece, but it's still a lot of work. And what people like to do is, you know, I have to get this product into production, I've got a budget, I'm going to buy my hardware, and I'm going to stick it out there. And then they don't really think about the fact that they've got it months in advance of when they really needed it. So that's ideal. That's as good as you can get, right? Maybe you're probably, over the lifetime of this product, you're maybe buying up to half the capacity extra than you really needed, compared to buying it only just what you needed exactly when you needed it, right? I mean, you could argue whether it's 10% or 60%, but there's a good chunk of extra capacity that you bought because you weren't right-sizing as you went. So that's ideal. But what typically happens is your product's uses way more capacity than you actually planned for, and you get this situation, that you get this mad scramble during the launch phase to add enough capacity to get the thing to work. So everything goes crazy, you underbought, and you're having outages, and it affects the product's launch. So that's not good. So, well, to make sure this doesn't happen, you buy extra capacity to be really sure that you have enough. Then you have this problem that you launch your product, and it turns out it fizzles a bit, you didn't use that capacity anyway, and you've got masses and masses of extra capacity, right? So given that these two options, you tend to want to always buy extra capacity than you need, right? And that's kind of the successful side of it for a product launch. So it's quite often you're buying a lot more than you actually need because you don't really know what you need, and you can't give it back. When you can't shrink to fit later. So as well as the launch capacity, you can think about, you know, you've got your production capacity, and generally production loads aren't constant. People say, well, you know, if I just have a constant load, it would be, you know, I could buy it for this, and the cloud cost would be this. People who have totally constant loads for 3 years are in very uninteresting businesses, right? They're not growing, they're just flatlined, you know. It's like that, you know, at the hospital when you get that constant beep noise, you know, you're dead, right? So interesting businesses are growing. And in 3 years' time, you'll need more capacity than you have now. That's just the way that things should be. And most businesses have more cyclic use cases, like customers go away during the night, or there's there's a sports event, or there's a marketing campaign, or there's something that will cause you to have more traffic, right? That's the whole point of having these machines out there, is they're servicing customers to generate more traffic. There are certainly cases where you can soak up all traffic, like some of the HPC workloads for drug discovery. You can make everything busy all the time. But those are, you know, that's a specific case, and there you use people like the cycle computing guys, where they run, you know, 70,000 spot instances for 4 hours, and then they're done, right? That's another way of doing that. The other thing is test environments. You know, your test people don't generally work all the time, right? You know, you could turn that stuff off when you're not using it. And developers as well, out of hours. And then there's data science. You're not always doing data science, right? You don't always have your people cranking away on your Hadoop clusters. So your Hadoop clusters may be a little bit idle at some times because, you know, everyone's gone home, right? So what can you do? You can shrink these things. So you can turn them off. And I haven't really seen a product that does this yet, but it's certainly something that I think Docker makes more and more reasonable to do. Since you can start stuff up with Docker in seconds, you should be able to just snapshot it in seconds too, right? Remember the current state, and all you've got left is the disk space. So you go for a cup of coffee and turn everything off for 10 minutes, maybe, or go for lunch, or certainly turn it off at night, right? Because when you come back, it takes a few seconds to bring everything back again for starting the containers. So think of container starting as being sort of a 1 second thing. Right? I can start a lot of containers in the time it takes. Some of you maybe have Windows laptops where every time you shut them down, you shut down the operating system, and then when you open it up again, you have to boot it again, and it takes 5-10 minutes before you can use Windows. And then other people have Mac laptops where you open the lid, and half a second later you can start typing, right? It's much nicer, right? So that's sort of the difference here. Do you want to reboot everything, or do you just want to open it up and keep going? So let's figure out how to build systems that freeze and unfreeze development and test environments, because there are 168 hours in a week, right? And averaged over the whole year, I mean, even 40 hours a week average is probably optimistic for how much time people actually spend working on stuff, right? So they're in meetings. There's all kinds of reasons why you're not actually using your environment. So you end up just paying the storage cost, which is typically fairly small for these things. So you can do it with AMIs, you can do it with Docker. I think that there's lots of good ways to do this. So that you could save a lot. And then there's seasonality. This is an example that Janesh put together for companies that are, like Intuit maybe, that are busy at tax season, outside tax season, less work, right? Or that you're busy at Christmas, or you're busy around the Super Bowl, or something, right? There's a reason why you're busy at certain times of the year, and the rest of the time it drops back again. In the summer, it's sunny outside, fewer people watch Netflix. They don't quit their accounts usually, but there's less watching of Netflix, fewer hours. And in the winter when it's dark, people tend to spend more time inside. So you get those kinds of cycles. The idea here is that rather than flatlining your load to take you through the whole year, you turn stuff off when you don't need it, and you could save maybe 50% of your total capacity by only having the seasonal capacity when you need it. So that's another right-sizing kind of thing. And then this is a graph from Netflix, from before and after graph from when we started using auto-scaling on one of the clusters. The big chunks in it are where we were running sort of blue-green deployments, and we had double the capacity running for a while because half of it wasn't working right, and the other half was some new version. So there's some side-by-side versioning. But you can see the left-hand side of this is the sort of overcapacity stuff that we needed because we were fixed-sized our autoscalers. We weren't automatically scaling them. And then we went to dynamic autoscaling and started scaling up and down. You can see on the right, every day it goes up and down by 70%. The overall area under the curve, because the peak is lower and there's troughs as well, works out about 50%. So just putting autoscaling on a typical daily cycle of customer behavior saves you roughly 50%. So that was fine, except it was reactive. It was like after the traffic had gone away, you would turn off the machines, and when new extra traffic arrived, you sort of scrambled to get more machines loaded. That's reactive auto-scaling, which saves around 50%. But there's times when traffic rushes in a fairly predictable way. Like Saturday mornings, all the kids in the East Coast suddenly get up at the same time because daylight, and they all start watching their dinosaur cartoons or whatever it is they watch. And there's a huge rush of traffic, and we found that the autoscalers couldn't quite keep up with some of these inrushes of traffic, but which were predictable. So they built an algorithm called Scryer, there's a blog post about it, which does predictive autoscaling. It sets the minimum value for the autoscaler. So you can still, if you get more traffic, it'll go higher, but it sets the minimum, right? It controls, there's 3 numbers for the autoscaler, the current, max, and min. This drives the minimum up and down to a level which is the level that we predict we're going to need, the minimum level we're going to need. And it aggressively drives down when traffic drops. So we know that after peak, the traffic's going to drop off, so it plans that down. So you get a deeper low, and you get a more aggressive shutdown of capacity, and it tends to catch the upswings earlier, so you get fewer outages. So this ended up with a better performing system. Load averages were lower, response times were better. And also it saved about another 20%. So this, with really sophisticated autoscaling, you can maybe get to 70% savings over fixed size systems that are have enough capacity to deal with that week's traffic. So that's a very powerful technique. There's 2 blog posts describing the algorithms that they use, although it's not an open source project at this point. So there's a bunch of other stuff that you left lying around because you forgot it was there, and Trusted Advisor will figure it out. It'll find you're not using these elastic IPs, there's some underutilized instances, there may be some snapshots or disconnected EBS volumes that are lying around. So this product, I think, at one point it was you had to have the premium support offering to get it. I think they've made the Trusted Advisor more and more of a free option now. It's sort of bundled into anyone can use it. But I think that Trusted Advisor is itself underutilized and underused, although it actually will tell you that as well. So you want to turn off stuff, delete things. There's a janitor monkey that Netflix built, which runs around cleaning up resources as well. So it's another tool you could perhaps use to figure this out. And the other thing, the nice feature of S3 is that you can expire objects. You can say, if you're doing archives, you can set a 30-day or a 90-day expiry on a bucket, and it will just delete all the old objects for you. So it tidies itself up without you having to remember to go do that. It's important. So how do you calculate total cost of operations? Well, it's apples and oranges, right? You have to include all of these things that people tend to forget. So, how much does it cost to get a place to put the machines, the power to it, the network pipes that come in and out, the people, and how do you automate the patterns? What software did you have to buy to automate those patterns? And if you're comparing sort of on-prem versus public cloud, you have to kind of figure out how much you're actually spending for something like ESX or OpenStack supported, to actually get all this working. So you got to bundle all those things in. It seems obvious, but I've seen people come up with numbers that just didn't include those and said, oh, it's free to run OpenStack because it's open source, and then they go and buy a Mirantis support license and find that actually it wasn't really free. And then another thing is, when are you paying? If you've got to get a building which you leased ages ago, then you install all the stuff in it, and then you store the racks of machines, and you install the private cloud software, and now you've got a private cloud, and you've spent a lot of money up to that point, and then you get to run your program in it. Whereas on AWS, you run your program, and they give you a bill a month later. So there's the capital, the cash flow is really nice to have it later, so that you kind of bake that into your cost model as well. The fact that you're paying in arrears instead of in advance, that you're offsetting your costs by maybe 6 months in some cases. So that's another factor to put in your model. And then reservations. So this is just, I picked a machine just as a sample. M3 Medium, it's a fairly standard machine that probably a lot of people use. On demand, it's, what is it, 7 cents an hour? And it works out to $18.40 if you run it for 3 years. So if you use reservations, you pay something up front, and then you get a lower price per hour. So heavy use, $337 up front, and you end up spending about as much again if you use it all the time later. So you can save up to 60%, 50%. It varies a little bit depending on what kind of machine it is. But this is just an example to give you, show you. Hopefully most of you have figured out how to use reservations. When I did this at Cloud Connect a year and a half ago, half the audience was baffled that this thing even existed. I think this is a little more sophisticated audience here. But you can save a lot of money by using reservations carefully. So what you want to do is blend this. You want to have a mixture of heavy utilization for your base load, and then you want to have some light utilization for the stuff that comes and goes. And then if there's any sudden peaks above that, it becomes on demand. But the area under that curve, that little on-demand area, is pretty small. So you're not buying very many instances at full price. You're buying most of it at sort of 50 to 60% discount. Right? So that's the key thing. But there's some other cool things here, because you consolidate your accounts. And this is where it gets a little bit tricky. This is one of those advanced topics. So let's say I have 5 different Amazon accounts. I can combine all those into a single bill. Well, that's convenient from a payment point of view. You probably all do that. And then it's also convenient because you get volume discounts, which are bundled together. So if you get a few extra % off because the dollar amount goes up rather than having them all individual. But the key thing here is that reserve instances are shared across accounts. And let's try and explain how that works. Let's say I have a production account, and all my reservations are against the production account. And I'm currently running a bunch of machines there. And if I ever say, I need another machine, I've got a reservation, I'm guaranteed to get it, right? Even if Amazon is out of capacity for some reason, I will get that machine because I've reserved it, right? That's really important, particularly if there's sort of outages going on, a fairly large spread. Everyone suddenly wants machines quickly. You can still get them because you have reservations. So it's an availability thing to give you a better capacity availability. But your QA and staging and all your other environments don't need reservations, right? So put all your reservations against the production account. Then what happens is, in practice, you actually only use 68 reservations in production. So but at the end of the month, all of the other accounts soak up the unused reservations. So you have reservations you didn't use in production, but the value of those is spread across all of the other accounts. So they borrow in this cross-count consolidation. Right, so it's kind of a nice thing that you can get reservations, you can get the reserve capacity, you can get this assured extra burst capacity if you need it, and you don't actually end up paying for it. You don't end up with unused reservations. That's the important thing. Right? So just getting your head around that takes a little bit, but it's a very neat trick. The other thing about reservations, that money you put up front, so if you're doing heavy use reservations, about half of the cost of the machine is paid up front. Right? You can take that, and that's a 3-year commitment, and you've paid it up front. You don't get that money back, right? The cool thing is, if you're in finance, you can capitalize it. You can actually amortize it over the 36 months. And not everyone figured out that you could do that. That's actually kind of an advanced topic for people. But take the reservation, the upfront payment part of your reservations, and get your finance people to amortize it over 3 years, and they'll be happy, because they like amortizing stuff, you know? It becomes like you're buying a machine and just paying for it over 3 years. You're sort of effectively, you are buying a machine. So, but you're buying half of a machine, half of the cost of a machine. So that's a neat trick. So you've got this burst capacity guarantee, you've got higher availability, you've saved your money, you're soaking up extra from other accounts, you get this monthly billing roll up across everything, and then you can capitalize the reservation charges. The only thing is that you've fixed your reservation. You're a fixed location, it's a fixed instance type, and you're locked into whatever it costs then, right? So if you think price cuts are about to happen, probably a bad time to buy reservations. Hold off a little bit, right? But you should lock in, lock it in for whatever capacity you actually need. So you're a little bit fixed. You've bought reservations in a certain zone because Amazon actually has machines in racks, and you are allocated. It's as if you bought the machine, right? You haven't bought a specific machine, but you've bought a proportion of the machines in that data center. That's the way to think about it. But if you actually turn out, oh, I didn't need that machine anymore, I want to move from M2s to M3s, well, there's a reservation marketplace, and you can buy and sell partially used reservations. I've got 2 years left on my 3-year thing, I'll sell it, and maybe I'll get some of my money back. Or if you want to buy reservations cheaply, you want to buy just 6 months or a year or something, you can buy discounted reservations in this marketplace. So again, it's a fairly sophisticated approach, but the capacity planning team at Netflix work for finance, right? That's what they do, right? The finance people. What they're doing is financially optimizing the spend, and they're not, they don't work in operations. Right? That's kind of where they'd normally be in most companies. Next thing, you want to size your instance to the workload. You don't just say, well, I have a pile of machines this big, and that's the standard thing, and I'll rattle my workload around in it. You can dynamically move the machines from size to size. And reservations double up. So if you bought, say, an M3 8 extra large reservation or something, or whatever it is, the 4X. Let's say the 2XL and the 4XL. And your application just about fits in the 2XL, and then the memory footprint gets a bit bigger and you have to flip to the 4XL. The reservations still count because it's actually you're just slicing the machine slightly differently, but you still get that reservation. So you can count the reservations across members of a family. You actually can vary the size. So now you need half as many machines because they have twice the CPU, but they have a bigger memory footprint. So quite often, that happened occasionally at Netflix, where the API server would get a bit fat for a while, and all of a sudden you'd run on half as many machines, but with more RAM. And then later on, we'd sort of cut it. It would shrink again, and we would run it on smaller machines. So there's a spreadsheet I have. I think it's called AWS instances or something like that. I have a bit.ly link for it. But I have all of these things. This is a log graph of the performance versus size, and the axis disappeared somewhere. That was 110, 100, and 1,000 gigabytes along the bottom, just showing the big range that exists of different instance types and all the different families. Come on, where's my thing? I've got to poke this thing again. There we go. The other thing's the technology refresh. So about a year ago, AWS came out with a whole new set of families, right? The M3, C3, and really obsoleted the M1, M2. And this is one of the things you see. If people are benchmarking AWS, they always pick on the M1 because it's horribly slow and it's not very cost effective now because it's obsolete. So you see any benchmark that uses the M1 small as the benchmark, you know it's a bogus benchmark. That's how you tell, right? So always benchmark your competitor's obsolete thing against your new thing. That's one of the laws of benchmarking. But this is just to show you the difference, right? They're roughly the same memory footprint, but a lot more CPU performance. 46 ECUs per dollar instead of 23 to 26 ECUs per dollar. So that's 77% better. All you did was migrate to a newer version, a newer machine type. So whenever you're allocating, if you've got reservations, you're kind of locked into the old ones. You might want to migrate the reservations. But anything new, and it's really worth keeping up with the latest machine types. So another trick that Netflix does is that they have a large number of machines that are being auto-scaled up and down of a certain instance type. And at night, when it's scaled down, they allocate Hadoop clusters using EMR on exactly that same instance type, right? So machines which are API servers at peak are running Hadoop jobs to do the daily roll-up at midnight, right? Because you've given back, and there's a few hundred spare machines. So what happens is that you export a metric, which is the number of unused reservations of every type, and then you basically have jobs which claim chunks of those reservations to run things. So you have Hadoop clusters that just appear and disappear. So that's daily metrics roll up. The other thing I could do is movie encoding. There's always that extra stuff to be done for encoding movies. So those things with a cross-account sharing, they sort of roll up into that as well. So this is the summary that Janesh put this slide together as the 6 different things. So 6 ways to cut costs. Business agility by getting your profit more quickly, so that pays for things. It's business-driven auto-scaling architectures, scaling up and down as the load from the business scales up and down. Mixing your reserved instances with your on-demand and spot instances as well. I don't have a slide here on spot, but there's some, if you've got a workload which you can run on auto-scale onto spot instances, again, you can save. One company I was talking to halved their bill by moving most of their capacity to spot instances. Consolidated billing, reservations, optimizing what you're doing with instance types, and then moving things around, running sort of machines for free using spare capacity. Right, so I'm going through each of these different ways saves you, some amount of money, right? So most of the things I've said, you could possibly save 30% or 40% or 50%, right? So let's try and compound these things together. Oh, the other thing's price cut. So over a 3-year period, you can expect prices to cut by some amount. I mean, we could maybe, if Moore's law kicks in, maybe every year and a half, it's half the price. So after 3 years, it should be a quarter of the price. And I've just made this. But the area under this curve is maybe 30 to 40% less than as if you were paying full price for the whole time. So there's another saving there. So let's combine these things together. So let's say you're just doing lift and shift. You have a workload in the data center which has a fixed workload. It's not auto-scaling. There's no cloud native. You just want to move it into the cloud. So the first thing is there's some base amount of capacity that you bought, right? That you would have bought if you were in the data center. But you can right-size it so you don't need to buy as much capacity. You can wait. You don't have to buy it as soon, and you don't have to buy as much extra, because if you suddenly need a bit more capacity, you can just add it at any time you need to. But you're not trying to do anything seasonal. So we're not going to do any seasonal auto-scaling. We're not going to do any auto-scaling on day to day. We're going to reserve, though, because this is a solid workload. We'll do a maximum use reservations, get about a 60% discount on the reservations. But we're locked in then, and we can't really do a tech refresh. We can't go from the C3 to the C4 because we bought a reservation on a C3, right? So I won't include the sort of technology refresh. And taking a few price cuts into action, because the reservation price is locked, but the variable part, I think, still gets the price cuts. So what you end up with is, over a 3-year lifetime, you're paying about a quarter of what you would pay from the sort of naive thinking if I just bought this much capacity and ran it for 3 years. So that's a decent amount of saving, compounding it in. But we can do better than that, right? So this is, you know, if you just start optimizing, this isn't the sort of, this is quite mild assumptions compared to the way Netflix runs stuff. So you're right-sizing, but then you've got some seasonal workloads where you give some capacity back when you don't use it. You're doing some auto-scaling during the day. You're reserving, you can use some tech refresh because you're mixing together some light use and heavy use reservations and some on-demand. So this is sort of a blended approach. And you know, I think you could probably get down to 15% instead of that 20 to 25% of the original cost. So you can get a fair amount of savings by just starting to auto-scale, and you gradually improve it. And I basically just assumed you save about 30% each time for these things. But you know, I think you can do better than that because there were Netflix was getting 50, 60%. So we can drive some of these things down. We can right-size more aggressively. We can do more seasonal right-sizing. We can use Scryer to get more aggressive daily scaling. And we can use a much more sophisticated blend of reservations if we particularly have a full-time finance person that's out there trying to save money, right? So it ends up looking like this. And when I multiply it together, you end up with 4% of the base price. So if starting off thinking I need to pay this much to buy my machines, you know, if you aggressively optimize all the way down and build a really cloud-native architecture, and all of these things kick in, you're maybe buying 4%. I mean, that would be pretty aggressive, but I was surprised that the number came out that small. So you think, you know, how can Netflix afford to run in the cloud? Well, they're only paying 4% of what you think they're paying. Maybe it's one way of looking at it, right? They're running a very large system, but they're running a very sophisticated way, and they're taking full advantage of all of these options to save money, right? So I've been talking a lot about this. There were lots of presentations this week. Netflix OSS, they recently, the announcement this week was that you can use Docker to play with this stuff. So it's very, very simple to get a lot of these tools working now. And the Netflix tech blog has lots of stuff on it. So this is, my last year at Netflix, I was really product managing and getting this thing out of the door. And I'm really happy to see them here almost a year later, still cranking out lots of new projects. Great, Rosalind and the team doing a lot of good work here. There's one project in particular I want to tell you about. I mean, there were some products out there that do cost optimization. There's Cloudalytics, I think. Is it Cloudalytics? Yeah, there's a bunch of tools. Crystallize, another one. There used to be one called NewVem that got bought by somebody. But there's all these tools that will help you optimize your costs, and there's the Amazon Trusted Advisor. But ICE is the tool Netflix built internally to do fine-grained tracking of costs and then allocate those costs to individual groups and individual applications, and then take a business metric and divide it in. So you could see how much Amazon cost was there per movie started, per streaming start. We could track that metrics like that. And then once a week you get an email to every manager saying this is your team's work, this is the work your team's using, and this is the budget that we've allocated for you. So it's not like you're doing full chargeback, but you're letting people know this is what you did, this is what happened over the last week, and this is your week-on-week delta. And if somebody suddenly uses twice as much cost as they were doing the week before, they'll go, well, yeah, we just launched this brand new personalization algorithm, we have 1,000 extra machines. Okay, that's fine, right? But if it was like, whoops, we left something running, you go turn it off. So it just keeps everybody informed, and the little bit of peer pressure. And then the other thing is that there's a performance team. You probably saw Brendan Gregg's talk. He works on that team. They go and find the biggest low-hanging watermelons they can find, not the little low-hanging grapes, the big fruit. And they go visit that team and they go work with them, right? So you have a performance team that goes after the biggest return, and they go and they tune stuff up. There was one example I remember where there was a service that ran on 600 machines, and they ran out a new security model. It's actually Missile, which was announced recently. When they first launched that. And it was fairly inefficiently configured. And that 600 machines auto-scaled up to 3,500 machines. Yeah, and they didn't turn it off and roll back. They just kept running. They just turned up the limit. And we'll run on 3.5 machines for a day or two while we fix this. one of the performance engineers went in and started tuning it and almost immediately got it down. He was knocking off 500 machines and another 500 machines. And over a period of about a week, he got it down to 150 machines total. So it ended up 4 times more efficient than the initial thing, right? So to keep tuning it in, but it was running beautifully scalably, and there were high utilization and low latency. So that use your performance tuning stuff to go after the biggest users, the largest consumers of CPU, which are using it most inefficiently, right? You don't have to tune everything, right? Because most things are too small to need it. But ICE will show you where that's happening. And it also knows about reservations on demand, and it will highlight all of those different things. It's quite a sophisticated tool. Okay, so final thoughts. Turn stuff off that's idle, clean up your unused entities, optimize for the pricing model that you've actually got. There's a lot of sophistication in there in the reservations model, and playing around with different combinations there is going to get you a good payback. Assume prices are going down if you're doing a comparison against on-prem versus off-prem, and go cloud native. And more aggressively you go cloud native, then you can get big savings out of that. So some links to things that I work for Battery Ventures. We have a blog called the Powered blog, which has a lot of articles by me on it. There's my own blog that's a little bit less active nowadays, but has a lot of stuff about AWS in it. And then my Twitter account that is still very active. I have stuff on SlideShare in 2 different accounts. One of them is mostly the Netflix stuff, and I started a new account when I joined Battery. So you'll find 2 separate SlideShares for me. One under the Netflix banner, they're all linked there, and the other one that isn't linked into Netflix. And I've done a lot of conference talks this year, so if you can go find videos for talks on monitoring tools and all of my sort of speeding up development, things like that. Well, the other thing that's interesting, and this is what's really, really fascinating right now, is what's going on in enterprise. And this book really summarizes it. Enterprises are adopting continuous delivery, DevOps, and lean startup at scale, and they're doing cloud, and this has been a fantastic year for that. You're seeing it here. Some of you maybe weren't at reInvent last year, right? There's a lot happening here, and it's a fascinating time to be in this space. Okay, I'd really like some feedback on this talk. I'm interested to hear what you think of it. Did you want something more technical? Did you think any of these numbers are bogus? I'm sort of a lot of arm-waving percentages here, right? So I'm trying to get something that seems reasonable. So I'd be very happy to get some feedback on it. And I'm going to evolve this talk. I'll be giving it again, a version of this talk in London in December, early December at a IEEE conference with a more academic focus. And then, I'll be around doing other events over the next year. So thanks, everybody.